On April 20th, 2010, the Deepwater Horizon disaster changed the lives of millions living near the Gulf of Mexico, as well as the scientists who responded to the crisis. These are some of their stories, intimate portraits of research, innovation, discovery. Welcome, I'm Jim McNamee, editor of Dispatches from the Gulf. In today's podcast, we'll hear from scientists working to understand the effects of dispersants sprayed during the Deepwater Horizon disaster. Dispersants are chemicals meant to help the cleanup effort by breaking oil apart into smaller droplets and keeping it from sticking to other surfaces. We'll hear first from Noshir Pesika. Dr. Pesika studies how oil sticks.
My name is Noshir Pesika, and my expertise is in understanding how surface chemistry and surface topography affect materials. So during an oil spill, the oil disperses and has the potential of sticking onto different marine surfaces, including bird feathers, the marsh grasses, corals, oyster shells. And so our interest lies in understanding how oils interact with these different surfaces to understand whether we can find new dispersants that would prevent the oils from actually adhering to these different surfaces. In the lab, what we do is, rather than using the actual surfaces from nature, we've fabricated model surfaces which mimic marine surfaces, ranging from very wetting surfaces that really liked oil, or surfaces that hate oil. So in a typical experiment, we'll watch an oil drop come close to a surface, and we'll record how the oil drop interacts with that surface, whether it prefers to remain as a droplet or whether it will spread on the surface. And if we see that it spreads on the surface, we can then measure the forces, the attraction forces between the oil droplet and the surface. We can also measure the extent to which this oil droplet spreads on the surface. And that information is very useful in determining how oils interact with a variety of surfaces. Ultimately, we want to use this sort of experiment where we can monitor how an oil interacts with surfaces so that we can get novel dispersants. So for example, we have some new dispersants that we're exploring where the dispersants will surround the oil droplet and actually act as a barrier, preventing the oil from interacting with the surface. Even though without the dispersants, they would naturally want to spread on the surface, but this dispersant will actually prevent the spreading from happening.
Our other voice for this episode is a marine biologist at the University of Miami. Dr. Claire Paris tells us about the role that turbulence and natural dispersion may have had during the Deepwater Horizon disaster.
The question that everybody was asking was how much oil is going to be coming up to the surface, and what is the impact of this oil on the marshes, the beaches, and the coastline, and the surface of the water. So the dispersant basically is making small droplet, and the small droplet are staying submerged. The big droplet are rising. Applying dispersant would prevent the oil to come to the surface. So you have to understand how much energy there is at the wellhead, where the oil was spewing, what is the kind of turbulence that would create the oil droplet. We don't really know whether the mechanisms of high pressure and the mixing of gas and oil could be creating maybe a natural mechanism for dispersion. It's a little bit like looking at, say, a cappuccino machine, where you have a lot of vapor with water getting mixed and making all these little droplets of water. So here you have a lot of pressure coming out of the well and cold water mixed with the warm oil coming out.
Dr. Paris acknowledges that chemicals like Corexit help to keep leaked oil from reaching the sea's surface. That said, she thinks turbulence was another big dispersing factor, with important implications for responding to future spills.
One thing was surprising to me is the little knowledge people had about the processes in deep water. When you have an oil spill in shallow water, everything comes up to the surface, so the response is already been in place for this kind of oil spill. But for the deep water, even though we have a lot of wells. We don't really know the mechanisms when there is a blowout in terms of the role of high pressure and the mixing of gas and oil. And so what I learned from the application of dispersant is that you can actually mitigate the damage to the surface by applying dispersant that decreases the size of the droplets so they stay submerged. But there is some physical mechanism that could actually disperse the oil naturally without having to use the chemical dispersant, and that's what we discovered by doing the modeling exercise. I think in the future what we will do differently is the first response. Using this kind of modeling, we can make decision on whether or not we have to use chemical dispersants to remediate for the oil spill. In most of the case, perhaps we will not have to do that because there would be enough natural dispersion.
Today, thousands of scientists, oceanographers, chemists, engineers, biologists are all working together to develop newer and better ways to understand and ease the impact of oil spills. To learn more about their work, visit our webpage at dispatchesfromthegulf.com. Funding for this podcast was provided by a grant by the Gulf of Mexico Research Initiative. And thanks for listening.